Quiz 2. Bring in my favorite student, good old Dan. Key idea here, I'm in orbit. I'm in orbit. Which means I can say gravity is what's pulling me around in a circle. What do they want me to find in part A? Orbital speed. So I'm going to start out by going, okay, gravity is what's pulling me around in a circle. Big G, big M, little m over r squared equals m. I'm going to use the v squared over r because they said speed. Now, they gave me a radius. I would have Riley no problem giving you an altitude instead of a radius, in which case you'd have to add the radius of the planet. That's fair game as far as I'm concerned. Makes it a tiny bit trickier. You know what? I've seen this one before. V ends up being the square root of big G, big M over R. Double check, are we around the Earth? I think on the test, on at least one question, just for giggles to be different, I think I put you around the moon. So Alon, read the questions carefully. Make sure you use the right mass and the right radius. Every year I have one kid who puts 5.98 times 10 to the 24th in every question. Read it. I want to dream about going to the moon, and so why can't I put that on a test question? Anyways, 6.67 times 10 to the negative 11, 5.98 times 10 to the 24th. What's my orbital radius? 8.1 times 10 to the 8th squared. No, one of the r's canceled here. Orbital speed is going to end up being 6.67 times 10 to the negative 11, 5.98, 10 to the 24th, divided by 8. Oh, 8.1, Mr. Dueck, times 10 to the 8th. Is that right? Square root. I'm expecting an answer, what, in the thousands probably, right? We've done a few of these. Oh, okay, 700, is that right, 701? A low orbital speed. You know why? Because that's a really, really huge orbital radius. That thing is way, way, way out there. We said actually in our last lesson, the further out you are, the slower your speed can be. So you don't need as much rocket fuel to keep it in orbit to get the kinetic energy, but you need more rocket fuel to get it out that far. So it's can't win anyways. 702, I guess, technically, yeah? If you got that 1 out of 1, sorry, 2 out of 2. Otherwise, I usually give a half mark for that, half mark for that, half mark for that, and a half mark for the answer. Oh, what's the kinetic energy? Sheesh. It's going to be a half mv squared. And conveniently, I just found v on my calculator. It's going to be a half 2500 702 squared. Wow, 6.16 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8. Is that right? And it's energy, joules. Probably I'd give you half mark for that, half mark for that, and 1 mark for the answer. Now, if, Jeff, you got the answer to A wrong, but you dropped it down and you went 0.5 times 2500 times your answer from A squared, I'll give you 2 out of 2 for part B, assuming you did it correctly. Okay, now they're giving me the period, and they want the radius. But here is the key idea. I'm in orbit. What does that mean? Well, that means that gravity is what's pulling me in a circle. Big G, big M, little m, all over r squared equals m. I'll use the 4, the pi squared, r over t squared. Does an R cancel here? No. Ah, an M does. They want me to get the R by itself. Well, I guess this is going to move to there and become an R cubed. And the T squared moves there. You know what? I think I'm going to get this. R cubed equals big G, big M, T squared all over 4 pi squared. How to get rid of a cubed? I think this is that one that, holy smokes, there's a use for cube root. Yeah, there is. Which is going to be the cube root of 6.67 times 10 to the negative 11. 5 point, are we Earth? Yeah, 98 times 10 to the 24th. 2.4 times 10 to the 4th squared. Almost forgot that. All over 4 pi squared. .98 times 10 to the 24th times 2.4 times 10 to the 4th squared divided by bracket 4 pi squared. Looks good. Cube root. Oh, math. Cube root. Answer. Do you get that? 1 point. I guess it's going to be 1.80 times 10 to the 1, 2, 3, 4, 5, 6, 7. Meters. The first time I made up this question, I was just making up numbers, and I made the period way too small. 'Cause when we found the radius, it ended up being inside the Earth. Whoops. Sorry. So this one is much bigger. I think I added a 0. I think I went from a 10 to the 3rd to a 10 to the 4th or something like that. And what's B want me to find? The gravitational potential energy relative to 0 at infinity. What's that? Relative to 0 at infinity? It's saying, look, go cosmic. Now, even if they hadn't said that, Riley, because I'm in orbit, I'm pretty sure I would have instinctively used the cosmic one anyways. Definitely when they use that trigger phrase, make sure I use not MGH. Did they want me to find how much work? No. Did they want me to find to change it? No. All they said is, what is the gravitational potential energy of the satellite? I think it's going to be straight plug and chug. In fact, I'm a little curious why I made this worth 3 marks. But it's going to be. Negative 6.67 times 10 to the negative 11. 5.98 times 10 to the 24th. 1200 divided by 1.80 times 10 to the 7th. But I'll use my answer button. Negative 6.67 times 10 to the negative 11. 5.98 times 10 to the 24th. 1200 divided by answer button. Does that look right? Do you get negative 2.66 times 10 to the 10th joules? What is that saying? Is that saying it doesn't have energy? Is that saying it wouldn't fall down? No. It's saying if you wanted to get to the edge of the universe, how much energy would you have at the edge of the universe out at infinity? 0. You would have to add positive 2.66 times 10 to the 10th joules to get it to the edge of the universe. You'd have to burn that much rocket fuel. So, although the negative at first seems scary, because we've defined 0 to be relative to infinity, we're good. Is that okay?
If you leave your answer without putting in scientific notation, will you dot marks?
You wrote all that out?
Not that one, but for previous.
This one here? I like answers to 2 or 3 sig figs. The answer is, when we had a provincial exam, when they actually took marks off if you didn't go to 2 or 3 sig figs, then I hammered kids because it was a dumb way to lose marks on the provincial. Usually now I put a frowny face, or it's less work, 2 or 3 sig figs. It's easier, 2 or 3 sig figs. I usually go 4 or 5 sig figs for intermediate steps. Final answer, though, 2 or 3 sig figs. It's less work. Speaking of less work, how much work? Good segue. Want you all to underline the word lifted. Are we in orbit? No. In other words, this is like that picture of the rocket ship where we went, and we were still facing away from the Earth, and we're going to fall back down. What I'm saying is, I'm still going to start out saying work is change in potential plus change in kinetic. Are we in orbit? Compare that with are we in orbit? Do we have kinetic energy? Yes, don't cross it out. And the reason I say that is I am going to give you a question like number 4 on your test. And every year, kids do this. And the problem is I gave 3 marks out of 7 for finding the kinetic energy. They've just guaranteed the best they can do is 4 out of 7. Don't do that. Let's go back here. What's changing anything? Final minus initial. Are we cosmic? Yep. Negative. Big G, big M, little m. Our final minus negative big G, big M, little m over our initial is going to be negative 6. Come on, pen. Let's try that again without the freeze. 6.67 times 10 to the negative 11. Are we on the Earth? Yep. 5.98 times 10 to the 24th. 6450 all over 6.38 times 10 to the 6th plus 4.6 times 10 to the 5th. Why did I add that? Because that's an altitude. Plus ditto mark, ditto mark, ditto mark all over 6.38 times 10 to the 6th. I'm going to type in one term at a time. Oh, that's the wrong button. Negative 11, 5.98 times 10 to the 24th, 6450 divided by bracket 6.38, scientific notation button 6, plus 4.6, scientific notation button 5. Did I type that in right? Looks good. I'll carry this, Jake, to like 5 sig figs, and then I'm going to do more math. So negative 3.7612. Heck, negative 3.7612. Negative 3.7612 plus, delete the negative, delete the plus, pluck, 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 pluck. Positive 4.0324 times 10 to the 11th. 4.0324. 4.0324 times 10 to the 11th. Is that right?
Yeah.
Oh. You had a phone go off? Oh, okay. I'll keep an ear out. Minus 3.7612 times 10 to the... You know what? I forgot to write the times 10 to the here. That was silly of me. Whoops. 11th. Do y'all get 2.71 times 10 to the 10th? I'll take 2.70, 2.72, 2.7, but 2.71 times 10 to the 10th joules? I'd probably go half mark, 1 mark, 1 mark, something like that. Ding 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 ding. Moon. Hopefully you caught that. What do you want to find first? Change in potential or change in kinetic? Okay. So change in potential is going to be, just to save room, I know it's final minus initial, negative big G, big M, little m all over R final minus negative big G, big M, little m all over R initial, which is going to be negative 6.67 times 10 to the negative 11. I have no idea. What's the mass of the moon? 7 point something, if I recall.
7.35
To the
times
22. Mass of the satellite is 1,600. All over. What's the radius of the moon?
1.74 times 10.
That's the radius, and they gave me the height above the moon, so I have to add it because it's an altitude. Minus minus is a plus. Ditto mark, ditto mark, ditto mark over 1.74 times 10 to the 6th. The change in potential is going to be (6.67) scientific notation negative 11 times 7.35 scientific notation 22 times 1,600 divided by bracket 1.74 scientific notation button 6 plus 2.0 scientific notation button 6. Is that right? 2.0973 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9. 2.0973 negative, Mr. Dueck. 2.0973 times 10 to the 9th. I forgot to put the negative sign in, but I added that, caught myself. Plus 4.508 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8. 4.508 times 10 to the 9. So it's going to be that. Take away 2.0973 times 10 to the 9th. Is the change in potential that? 2.4107 times 10 to the 9th. 2.4107. Put a box around that because I'm going to use it later. Change in kinetic is going to be final minus initial. We're going to assume we start at rest. A half mv orb squared. Now, this is important. I'm going to give you a hint about the test. In this question, did they give me v, the orbital speed? Yes. See it? So this is easier. On your test, I'm not going to give you orbital speed. However, if you know the radius, can you not find the orbital speed by hand, like we did in part A? In other words, I'll combine everything in one big uber question. I would have no problem not giving you the speed and say, while you're at it, find the speed, Chief. Because it really, I mean, it's putting the entire unit together in one nice question. I kind of like that. But here, they gave me the speed, so it is going to be basically plug and chug. It's going to be 0.5 times 1,600 times 1.15 times 10 to the 3 squared. How much kinetic energy does it have? 1058000, that much. 1.058 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9. How much work? Add the two boxes together. 2.4107 times 10 to the 9th plus 1.058 times 10 to the 9th plus 2.4107 times 10 to the 9th. Do you guys get that? 3.47 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9. 3.47 times 10 to the 9th? Is that right?
Yeah.
Now, on the quiz, I made this worth 3 marks, which is way too little. I would go like this. I would probably give you a half mark if I saw that. I would give you 1 mark if you found the change in potential. I would give you 1 mark if you found the change in kinetic. And then I would give you a half mark for your final answer for your total of 3 marks. Can you give yourself a score, please, out of 15?